This is a solution to a STEP question. It's taken from Step 1 in 2004. It was question 1. It comes in 3 parts. The first part is relatively straightforward, the sort of thing you might find in an A-level question. The second part, we need a little bit of rearrangement here, as we'll discuss. And the third part is a heavily disguised quadratic equation. So let's look at the first part. This is testing your ability to expand some algebra efficiently. I start by looking at Pascal's triangle at ascending powers of 3 and at descending powers of 2 root 5. Now 2 root 5 squared will be 4 times 5, which is 20. I'll multiply that by 2 root 5, I'll get 40 root 5. We now need to collect together the rational and irrational parts. This is 3 times 3 times 20, that's 180. And 1 times 27, that's going to give me 207. And the irrational parts are 3 times 9, 27 times 2, that's 54 root 5. And another 40 root 5, that's 94 root 5. And we've completed the first part of the question. Okay. It's also given us a hint. It tells us that we're pretty good at cubes. We are less good at cube roots. So when we look at this spring about finding the cube root, really we need to rephrase the question as this side cube is equal to the 99 minus 70 root 2. Now as before, let's proceed with expanding this side. I've got 1, 3, 3, 1 from Pascal's triangle. I've got 1 c, c squared and c cubed from the ascending powers of c. I've got 1 minus d root 2 plus 2d squared and minus 2 root 2d cubed from my descending powers of minus d root 2. I now need to collect together the rational and the irrational parts. The rational part will be a c cubed, and 3 2's are 6c d squared. My irrational part will be a 3 times d c squared times root 2 and a 2 root 2 d cubed. And I've left out the minus sign. We'll deal with that shortly. I compare this now with my 99 minus 70 root 2. The rational part will be equal to 99 and the irrational part will be equal to 70, and you'll notice the minus sign there and the minus sign here we've left out. I can also get rid of the root 2 simply by cancelling and work out that 3d c squared plus 2d cubed is equal to 70. I've got two simultaneous equations, and those should be very easy. However, if I try to solve them by proper algebraic techniques, it might take me a long time, so I need to read the question carefully, and the important part is that c and d are positive integers. Right. Now let's look at this equation here. 6cd squared will be positive and it will be even, which means c cubed must be odd. So I'm looking at c cubed plus 6cd squared equal to 99. C is an odd number. It could be 1, it could be 3, it couldn't be 5 because 125 plus a positive number can't be equal to 99. C can only be 1 or 3, and that makes this solution a lot easier. Let's try c equals 1. This would tell me that 6cd squared was equal to 98. But c is 1. So d squared is going to be 98 over 6, which is not an integer. D squared is not an integer, so d can't be an integer, and therefore c is not equal to 1. Now let's try c equal to 3. 27 plus 6 3s are 18d squared is equal to 99. D squared will be 99 take away 27, that's 72 over 18, that's 4, and d will be equal to 2. D won't be equal to minus 2 because it's a positive integer. Yeah? And therefore c equals 3, d equals 2 is our solution. Of course, good mathematicians check all the time. We also know from our previous work that 3dc squared plus 2t cubed should be equal to 90. Let's take the left hand side. D was 2, c was 3. So I've got 3 times 2 times 9, and I've got 2 times 8. This is equal to 6 9s are 54, and 2 8s are 16. So being good mathematicians, we've checked our answer, and our answer works. The final part of the question asked us to solve a quadratic. It's pretty obvious that won't factorise. So what we're going to do is we're going to rewrite it first of all in terms of u, which is the same as x cubed. So x to the 6 becomes u squared, x cubed becomes u, and since it won't factorise, we're going to complete the square. This involves adding 99 squared to both sides. The left hand side will be u plus minus 99 all squared, and the right hand side is the difference of two squares. So this is 100 times 98. A squared minus b squared is a plus b multiplied by a minus b. This means that u minus 99 will be plus or minus the square root of 100 times the square root of 98. And the square root out of 98 is the square root of 49 times 2. And u will be equal to 99 plus 70 root 2, or 99 minus 70 root 2. If we go back to the original question, we like that. This is obviously referring back to previous results. So, if x cubed is equal to 99 minus 70 root 2, then x is going to be equal to c minus d root 2, which is going to be 3 minus 2 root 2. If, on the other hand, x cubed is equal to 99 plus 70 root 2, we don't need to go all the way back and do all the algebra again. It should be quite obvious that x will be equal to 3 plus 2 root 2, and the question is complete.